All right. So today's notes, as I mentioned before I started recording the video, are on the inverse tangent function. And I'm not going to draw out the tangent function like I did for sine and cosine when I was teaching you why that they have to be, your domain had to be restricted, right? Because your sine and cosine were a function, but the inverse was not a function because it did not pass the horizontal line test, right? Well, same thing with tangent. Tangent technically doesn't have an inverse because the inverse, well, the tangent function would not pass the horizontal line test, so it's not a one-to-one. So for tangent, we also have to restrict the domain. So instead of doing the whole tangent thing and showing you again, I'm just going to tell you what the domain is restricted to, okay? So, denoted by tan with a little exponent of -1, but we know that's really not an exponent when we're talking about inverses. Add x is the inverse of the tangent function when the domain is restricted for values of x that are between -pi12 and +pi12. So if you recall when we graphed tangent, just y equals tangent at x, the most basic with nothing is shift, your like first main period starts at -pi12 and goes to +pi12. All right, and remember tangent, you have the asymptotes, right? And so from -pi12 to +pi12 are where those two main asymptotes were, and then tangent function goes, I did it wrong, goes like this in between. That is terrible. Or actually like this. There's one in between -pi12 and +pi12. And I know you can't read that, but open your notes and go back and look at tangent, the very first, the original one we did. And then that just repeats on and on to the left and to the right. So if we want to find the inverse, we have to restrict the domain. And so we're just restricting it -pi12, +pi12. Notice I did not include -pi12 and +pi12 because at those values of x, it's undefined. That's where the asymptotes are. So that's why we didn't put the little x's under there. Which I'm going to write next. Tangent is undefined. At -pi12 and +pi12. Therefore, those values aren't included in the domain. All right, y'all ready? So also remember, tangent means, that's MEANS, means y divided by x. Or, when we're talking about the unit circle, sine of theta divided by cosine of theta. And all of the problems that we're going to do are going to be problems that can be found on the unit circle. Okay, remember, you have other degrees besides 30 degrees, 60 degrees, 90 degrees, 120 degrees, all those things. And those you can use your calculator for. But we're going to find exact values, so we don't want any decimals, and your calculator just gives you decimals. Okay, can you take your earbuds out, please? But I'm actually not going to give you an assignment on it because every question that I would ask you, we're going to actually put right on the graph. Okay, so drawing this unit circle is important because we're going to put all the answers right there. So I'm going to draw a large and in charge unit circle. And my domain is restricted from negative pi halves to positive pi halves. So if we started at 0, negative pi halves would be clockwise 90 degrees, right? And remember, at negative pi halves, it's not included. And from that point all the way to positive pi halves, and at positive pi halves, it is not included either because those are where the asymptotes are on the graph. Open circles there. And we're going to find the inverse of 30 degrees, 60 degrees, 45 degrees, negative 30 degrees, negative 45 degrees, negative 60 degrees, okay? Within these two quadrants, quadrant 1 and quadrant 4. So first, to do that, we need to know the sine and the cosine of each of those, right? So let's make our little triangles, go through and figure out the sine and cosine. Once we do all that, then we'll find the tangent. Coolio? All right, so let's do 30 degrees. What's the measure of the leg across from the 30-degree angle? 1/2. And what's the measure of the leg across from the 60-degree angle? Square root of 3 over 2. So what's my cosine at 30 degrees? Square root of 3 over 2. What is my sine? 1/2. Let's do a 45-degree angle. So we know 45-degree angles, the legs are the same of the 45-degree angles, right? And we know that the hypotenuse is 1, but to find sine and cosine in a unit circle, I don't care what the hypotenuse is because it's always 1, so that's going to make it easy. So what is my cosine? Square root of 2 over 2. And what is my sine? Square root of 2 over 2. All right, and then let's do 60-degree angle. So the leg across from the 30-degree angle is 1/2. The leg across from the 60-degree angle is square root of 3 over 2. So what is my cosine of a 60-degree angle? 1/2. And what is my sine? Square root of 3 over 2. All right, so before we can find the inverse of tangent, let's first figure out what tangent is. Oh, wait, let's do the other quadrant as well. So I kind of know that we're going negative. So I'm going to go down negative 30 degrees, negative 45 degrees, and negative 60 degrees, right? So the only thing that's different, my negative 30-degree angle, what's the cosine going to be? Cosine. Square root of 3 over 2, and the sine is negative 1/2. Very good, because all of your y values in this quadrant are negative. So for my 45-degree angle, so that's 30. For the 45-degree angle, what's your cosine? Square root of 2 over 2, comma, sine, negative square root of 2 over 2. So my next angle is the 60-degree angle. Cosine is 1/2, and your sine is, very good. Okay, so let's figure out what the tangent is for each of these. So for the tangent, just tangent, now we're talking about inverse tangent, right? But let's figure out what the tangent is first. So for the tangent, we're going to find the tangent of a 30-degree angle. So I'm going to do sine divided by cosine to figure that out. So I'm going to do 1/2 divided by the square root of 3 over 2. So I'm going to do my math down here. 1/2 divided by the square root of 3 over 2. So let's get rid of that complex fraction first. Multiply by 2, right? And that will get rid of the complex fraction, and we're left with 1 divided by the square root of 3. Well, can you leave a radical in the denominator? No, we need to rationalize it, right? So what would we multiply this fraction by? Very good. So numerator times numerator, 1 times the square root of 3 is the square root of 3. What is square root of 3 times the square root of 3? Square root of 9, which is 3. Now, can I cancel out those 3's? No, because this is the square root of 3 divided by 3, not 3 divided by 3. Square root of 3 is like 1.7 something. That does not reduce with 3. So the tangent of my 30-degree angle is the square root of 3 over 3. That's the tangent. All right, let's do 45, 45, 90. So our sine is the square root of 2 divided by 2, divided by the cosine is square root of 2 divided by 2. Well, what's the square root of 2 divided by 2 divided by square root of 2 divided by 2? 1. So the tangent of the 45-degree angle is 1. And let's do the 60-degree angle. Okay. So we have square root of 3 over 2 divided by 1/2. Complex fraction. And now I'm left with the square root of 3 over 1, or just the square root of 3. So what is going to be the tangent of my negative 30-degree angle? Negative square root of 3 over 3, right, because it's going to be negative divided by positive. What's going to be the tangent of my 45-degree angle? Negative, What'd y'all say? 1. And what's going to be the tangent of my 60-degree angle? Negative square root of 3. All right, so remember, when you're talking about inverse functions, I'm saying, if I said, what's the inverse of square root of 3 over 3? In degrees, what would you say? What angle gave you a tangent of square root of 3 over 3? 30 degrees, right? That's what inverse means. And then I would convert 30 degrees to radians. So, well, I guess let's just do that. So if I said, example 1, inverse tangent of square root of 3 over 3. On this one, I will let you look at the unit circle because, like, we know sine and cosine, right? But tangent, we're not so familiar with that. So we said the angle that gave us a tangent of square root of 3 over 3 is the 30-degree angle. So we know that's the 30-degree angle. However, we're going to convert it to radians. So I'm going to put multiply, not equals. Multiply by pi over 180 degrees. And I get what? Pi 6. Example 2. What's the inverse tangent of at 1? And you can tell it to me in degrees. 45 degrees, right? So let's convert that to radians. And what is that in radians? Pi fourths. Example 3. What's the inverse tangent at the square root of 3? 60 degrees. What is 60 degrees in radians? Pi thirds. Let's do the negative. What is the inverse tangent at negative square root of 3 over 3? Negative 30 degrees, which is going to be what in radians? Negative pi over 6. Example 5. What is the inverse tangent at negative 1? Negative 45 degrees, which is what in radians? Negative pi over 4. Example 6, you guessed it. What's the inverse tangent of negative square root of 3? Negative 60 degrees, which is in radians negative pi thirds, right? Anybody have a question? Anybody confused? Does anybody want to do more work? All right, so I'm not going to give you an assignment because these are all the questions I would ask you anyway, right? So that is the very end of module 3. We are done with module 3. Boom. Normally, I would be giving you a test over module 3 that we've been working on since November. But because I was out for 10 school days, which put us behind, and we have worked on this over and over and over. I feel pretty confident that we're pretty good. We will just start right into module 4 next class. So what I'm going to do during this class, it's only 10:50. I'm going to pass back some papers. Sub work, there's nothing to make up. It was completion. But what we've done recently, things that I've graded for accuracy, I'm going to pass those back. And if you want to work on, if you want to do any corrections, I want you to do that at home. I've been working on grading everything. I don't know if I'm completely caught up, but I'll work on that while y'all are working on this. And if there's anything you want to make corrections on, please do that and resubmit to the assignment that you're making corrections on. Okay? I have a question about that. And then, so there is no assignment on this. Those of you at home,